I got, sorry.
We're trying to stay on track here. But thank you so much. We can just get a round of applause for our great speakers.
Thank you very much. So I'm Darren House. We also have Zhang Shen, who's going to be coming up here for a demo in a little bit. And we're here to talk to you about serverless cyber ops for government. And in this session, we're going to talk a little bit about why you might be here. We're going to discuss how this session could help solve some problems for you. We're going to tell a story, because who doesn't love a good story? And then we're going to dive into Amazon serverless technologies. We're going to provide a demo for you. And hopefully by the end of this, we'll have convinced you that Amazon serverless designs can help solve some big problems for government. So maybe this is one of the reasons why you're here. The realization that even though there's been a lot of attention on cyber, it seems to be a growing problem. Latest estimates are a $600 billion cybersecurity or cybercrime market out there today. That's huge. Maybe you're here because you read the daily cyber news and you keep seeing incidences, you keep seeing threats and vulnerabilities out there, and you're starting to wonder, who's next? What's going to happen? Maybe that's one of the reasons why you're here. And I would like to give a quick shout out. This report to the president that's on the front here, this came out just last month. In this report, it talked about using agile, innovative mechanisms to be able to create better cybersecurity solutions in your environment. And the goal number 2 is to promote the innovation for the infrastructure for dynamic adaptation to evolving threats. This is in this, the report that's there, and this is exactly what this session is all about. Using innovation in the infrastructure to dynamically adapt your environment based on the threats that are coming into your environment. And so this is not just for federal government, this is state and local, this is tribal governments, this is government everywhere, all right? Cybersecurity is a big problem, it's a complex problem, there's lots of stakeholders involved, and there's a lot of work to be done here. So I just want to make sure it's clear, it's everybody's problem. Now, before I go to the next slide, though, I do have a couple quick questions for you, and the first one is, who here has responsibility for cybersecurity in your organization? Okay, so the answer is everybody needs to raise their hand for this one, because everybody has a chance of being a victim of cybersecurity. Everybody is potentially a victim. So everybody has a responsibility for cybersecurity within their organization, okay? The next thing I want to ask is, so for those, I saw a couple hands come up, now let me ask this again, for those of you that work within cyber IT shops, the CISO shops, how many of you are in this room today? Okay, so we have a couple, there's not a lot, so let's, all right. I think I'm going to use that as my example for the next slide, because the question was going to be, how many of you think you have enough people in your organizations to actually solve all the problems you have today within cybersecurity? And the answer is, you don't. Cybersecurity is a big problem. It's a problem for all governments. And one of the biggest problems that there is to solve within cybersecurity today is the lack of skilled professionals to handle all the work that needs to be done within the cybersecurity environment. The cybersecurity environment is growing, $600 billion cybercrime market, and it seems to be growing. There's been articles about it, as you can see on the slide, and there's actually been legislation that's been introduced just last month about trying to train and retain highly skilled cybersecurity professionals. And now training and retaining is going to be part of that solution, but that's a long-term time horizon, okay? It's going to take years. When you get somebody in, you train them, you get them into the workforce to actually get the experience that they need to bring the value that you need in your organization. So what would you say if I told you that there is a way today to turn the people in this room into superheroes within your organization by using serverless technologies to give you the power of 100? One person has the ability to have power of more than just one person. With serverless, they do exactly what you want them to do, 24 hours a day, 7 days a week, 365 days a year, and they give you that capability. So I'm going to level set on a couple concepts here before we move forward, because we're going to talk much more about cybersecurity, serverless cybersecurity, and we're going to get into the story. But we're going to talk about cyber relevant time, okay? So cyber relevant time is a relative term that's about the time it takes for an attacker to attack you and move through different steps in what we call the Cyberkillchain, okay? And that's what we're going to reference it about. The Cyberkillchain is something that was invented by Lockheed Martin. It's a framework that identifies the steps that cyber attackers take to go from reconnaissance to breach of your system. And there's some patterns that happen within those steps. And between those patterns, there are things that you can do to stop it, or to thwart it, or to give yourself some more capabilities. So that's what the Cyberkillchain is. Cyber economics, that's the countermeasures and the defenses that you put in place to make it cost more for the attacker to attack you, right? In any environment, things eventually come down to a business choice. And business choices, these conversations end up revolving around cost, risk, and resources. So as the defenders, we have costs we have to deal with. We have to figure out what our risks are. We have to identify the resources that we have to try and do the defense piece. For the attacker side, they have similar choices and trade-offs they have to make. They have to determine the cost of attacking you versus somebody else. They have to determine the cost in terms of their time, their money, their resources. They have to identify or figure out what the risk is of getting caught, and they have to figure out the resources that they have and how they can use those resources to get what they want. That's cyber economics. It's an important part of the perspective that you have within cybersecurity, and it's going to have a role to play when we talk about cyber relevant time, the Cyberkillchain, and how it all comes together. Now, the last thing I want to get to make sure we're all on the same page is the difference between a compromise and a breach. So a compromise is when you have a system that has a vulnerability. The operating system or the application will have a vulnerability in it, and an attacker will exploit that vulnerability. Then that host becomes compromised. All right, so this is part of that Cyberkillchain where you get that compromise, but you still have things you can do. There's things you can do to countermeasure that compromise. Once that compromise has been settled, they have a beachhead within your environment, and they do some reconnaissance around your environment, and they identify the data that they want to get, and then they start pulling that data out of your environment. That's a breach, and you can't come back from a breach. So out of this, I want to make sure you understand, compromise, you still have things you can do. Breach, you can't come back from that because they have your data now. All right, so with this slide, we want to try and get you to think a little bit differently about how to solve the cybersecurity problem. We're going to take a philosophical approach, propose a business problem, and an architecture on AWS to help solve that problem. All right, and to start with the philosophy, I'm going to introduce a word, and this word is a Greek word. It's called metanoia. It means a shifting of the mind or a transformation of the heart that changes your behavior. And the reason this word is so important in the cloud is because it requires a change in the way you think and a change in the way you act to leverage cloud to get the greatest value possible for yourself, for your organization, and the people you're trying to protect. All right? You can lift and shift into the cloud, and you will get some value in there, but you won't get the greatest value. You won't be able to optimize that value if you don't shift the way you think a little bit and change some of the behaviors that you're taking. On the business side, I want you to think about cybersecurity as a business problem with technical dependencies. It's not a technology problem anymore. There are technologies out there to help take care of cybersecurity, but it's a business problem, the lack of skilled resources and professionals to handle this massive workload of work that needs to be done to identify threats, to react to threats, and have those capabilities. And lastly, there's an architectural perspective on how you design an event-based serverless architecture within your cloud environment to respond in cyber-relevant time to any kind of attacks or events that happen within your environment. So I'll give you a couple of examples quickly. So on the philosophy side, what does that mean to you? All right, first off, it means servers aren't pets. And I don't know if you've heard that phrase before, but back on the on-premise days, if you had a problem with a server, you would do open heart surgery and you'd take hours and hours and days trying to figure out what the problem is. In the cloud, a server or an instance is a unit of work that brings value to your organization. And if it stops bringing value, or if it increases your risk, kill it and bring up another one. You don't need to give it a special name. You don't need to care and feed it. You kill it and you bring up another one. That's the focus, and that's the key capability or a capability of cloud, especially if you use stateless design principles, using auto-scaling capabilities, those types of things to provide your architecture the ability to kill these instances, right, if you have problems. And we'll dive a little more into that in a moment. From the business perspective, it is a business problem with technical dependencies. You need to focus on the cyber economics. How can you increase the cyber economics to the adversary who's trying to get in? All right? How can you use the cyber relevant time between different stages in the kill chain to figure out how to do your architecture so that it's more cost effective for you? And on cost effective, you need to think about the countermeasures that you use should cost less than the actual risk that you're trying to prevent. All right, and let me give you an example for that. Would it make sense to spend $1 million to protect $10,000 worth of risk? That's not a very good business decision. It's a tough choice to make. But it'd be a really good decision to say, I'm going to spend $1 million to protect $10 million worth of risk. Right? That makes much more sense. And what we'd like to show you here is that by using cloud architectures, you can reduce the cost of those countermeasures to take care of that risk that you're talking about. And lastly, it's the architecture piece. Design your architectures for the Cyberkillchain. When you look at your architectures in the cloud, look at those different architectures as steps that an attacker can take, understanding a little bit of that cyber-relevant time between those steps in the kill chain, so that you can create countermeasures that will respond in cyber-relevant time without you having to have a large amount of people that are manually doing a lot of things, looking for events, trying to find out which ones matter, looking for false positives, all that stuff. So I have heard it said, and there's been some articles I've read about it, that serverless really isn't serverless because there's still servers in the background, so they don't really bring the value that people say they do. So I'm here to tell you that that is true. There are still servers in the back end, but that's not the point. All right? It's not the point. We take care of those servers, we take care of the security, we take care of the availability of it, we take care of all that stuff for you so you could realize the value that you're trying to achieve by going to the cloud and getting that value fast. That's how you can turn your FTE into superheroes, by having one person with the power of 10 or 100. Okay? So now I think we're going to go into a quick topic about two of the key cybersecurity capabilities or services that Amazon has, and then we'll get to the story, and then we'll get into a demo. So Amazon GuardDuty, that's our service for threat detection. And what that does is it takes VPC flow logs, which are the logs for flows of data going in and out of your VPC, your virtual private cloud environment. It looks at those. It looks at DNS logs. So any DNS queries that are coming in and out of your environment, it will look at those. Your CloudTrail logs, those are any API calls that go within your account. It takes all those and it does analysis on them. It uses machine learning algorithms to do analysis on them, and it also does data enrichment because we have third-party threat intelligence feeds. We have some from Amazon Security themselves, places like CrowdStrike and Proofpoint, that come in and provide extra data enrichment in your environment so that you have an analytics tool and you have third-party threat intelligence. And all this is done at a click of a button. I'm not exaggerating. To enable GuardDuty, you click, you want it on. And it takes care of your entire account, right there. Imagine how long it would take for you to set that up on your own environment, on premise, and how much work, and then not just setting it up, but managing and maintaining it, okay? So it's a great tool. It's a single click. The other cool thing about it is there's no agents to install. One of the things that the attackers commonly do when they try and get into your environment, if they get it compromised, they try and look at what's running on your environment and shut off agents that can identify them. They try and obfuscate what they're doing. You can't obfuscate something if there's no agent to turn off. The next one is Amazon Inspector. So Inspector does patch management capabilities. So common vulnerabilities and exposures, the CVEs. It can identify vulnerabilities, the common internet security issues, best practices. There's a whole bunch of different things you can do to run assessments against your instances in the AWS environment. And then you can it'll provide you with findings, and with those findings, you can do remediations of it. And one of the cool things with both GuardDuty and with Inspector, they are highly integrated with serverless capabilities like Lambda and step functions so that you can automate a lot of this. One example of these, and we'll talk a little bit about it, is the ability, so for GuardDuty, you can have a finding of somebody, if they're trying to do a reconnaissance in your environment, it'll provide a finding for you that shows that they're doing port scans. The third-party threat intelligence will provide information about if the source IP address or the DNS names that are coming from them, if those are known malicious attackers. You can take those two things and say, if these two things happen, then you know what, just in case, I'm going to kick off an automated function to say, hey, Lambda, go tell Inspector to inspect all my instances that they're scanning, just to make sure that I'm patched today. And then when you do that, if it comes up with some findings, you can have another Lambda function take those findings, pull the remediations, and automatically remediate the findings that they had. So some amazing capabilities. So now I'm going to tell you a story. And the story is going to be told within the Cyberkillchain framework. It's 6 chapters. The first chapter is about reconnaissance. The second chapter is about weaponization. And the third is going to be about delivery. Now, on one side, we have our antagonist, the mad hacker. On the other side, we have our hero. That's you. And you are a hero because you came to this great session at the Public Sector Summit and identified some serverless capabilities you could use that you implemented in your cloud environment. So the first part of this is the attacker has decided that they want to get your data. There's something you have that they want that they can monetize or they can get value from. So they look you up on social media. They try and find people that are in your organization on LinkedIn, on Twitter, on Facebook. They'll do public IP scans for your IP space. They'll try and find out the hosts, the ports and protocols that you're running, and they'll look for what's called fingerprinting. They'll try and get information about the operating systems, the flavors, the versions, the applications and application versions. All right, that's the first part of this cyber kill chain. It's the reconnaissance part. But you have GuardDuty to protect you. And when there's port scans that happen within your environment, GuardDuty can identify that for you, and it'll provide a finding. It'll be a low finding for you that you can do something with. Now, maybe you don't want to do anything because there's port scans that happen on the internet all the time. So maybe you don't want to do anything, or maybe you do want to do something if it's a known attacker. Maybe you can do some automation just to put that away in a database to say, hey, we've had this known attacker do this. Let's just track this for a little while and see what happens. But there are a lot of different things you can do in your environment based on this. So the second chapter after this is, okay, so they've done some reconnaissance. They found out the operating system you have and some applications that you have, and they looked up some vulnerabilities that are applicable to those. And so then they have a choice to make. They have to decide, what is the method? How am I going to weaponize my payload to try and get in there? I don't know for a fact that they have these vulnerabilities, but I know that this application does have a vulnerability. It's only been out for a couple months, so maybe they haven't patched yet. I'm going to weaponize with this. All right? Now, we don't know the cyber relevant time between the reconnaissance, between the weaponization, and between the delivery. All this happens on the attacker side, and it could be minutes to weeks, right? There are so many different kits out there that people can buy that they could weaponize something in a couple seconds. So the cyber relevant time is not quite known at this point, but the point is it could be hours or days, or it could be minutes. So they've decided that they're going to attack you. They've decided what threat they're going to use or what vulnerability they're going to try and exploit. And you have GuardDuty and you have Inspector to help that. So in the example I just gave a few moments ago, let's say it was a known malware or known bad person that was trying to get you. Let's say that you decided you're going to create some Lambda scripts or do a step function tying multiple Lambda scripts or Lambda functions together to automate. Because it's a known attacker, I'm going to check and scan my instances, and I'm going to automatically remediate those instances. Within that cyber relevant time, you could have plugged the holes that they could have exploited, but now they can't. And it was all automated, right? So you respond in cyber relevant time without having a lot of people have to do the work. So now they go to the delivery, and they're trying to figure out how they're going to deliver their payload into that server, right? There's lots of bots, crawlers, watering holes, phishing, but we have what's called the Web Application Firewall. That's another service that works for you. You don't have to manage any servers for it. You just do the configurations for it, and you can you can do the monitoring and the logging of what's happening in the environment. But the Web Application Firewall can identify SQL injection, cross-site scripting, those types of things, the different things that try and happen in the delivery phase, and you can block them. All right, so now we're getting to the climax of the story, because this is the definition of climax. It's a decisive moment that is of maximum intensity. And I don't know if any of you have been through a cyber attack, but they can be pretty intense when they're happening. And if you can avoid it, I would definitely recommend it. But so the next 3 chapters are exploitation, installation, and command and control. And now this is the area where we're talking about cyber relevant time, compromise, and breach. Okay? So this is important here. We still have the mad hacker. We still have you, our hero. And so they try and do a SQL injection. They try and use a CVE that's known to attack you, or they try and do a zero-day exploit in the exploitation phase. But you have the Web application firewall, you have inspector, and you have GuardDuty there to help protect you in this environment. Let's say it was a 0-day, all right? One of the great things about GuardDuty is that it has the anomaly detection capabilities. If somebody exploits your system, guess what happens? There's a behavior change that happens within that system once it gets exploited. It has to go out to try and get some sort of command and control. It has to install some files. It has to do something. And the behavior is going to change. It's a change in pattern that GuardDuty can identify. So another one, once they get to the backdoors, they're trying to do a backdoor, they have to install something to get persistence. Okay, so they need persistence to be able to do command and control, to do reconnaissance internally and get your data and breach you. All right, they'll try and put backdoors in, they'll try and put auto run into your environment to make the application or whatever it is, the tool that they're installing, make it run automatically every time the server boots. Might do registry keys, a number of things. Their whole goal, though, is to establish this base camp. And again, this is GuardDuty because it's a behavior change. All right? Now, the last piece is the persistence. They want to get persistence. They want to get into that environment that they've compromised. They want to look around. They want to do reconnaissance and see if they can move laterally to different systems to find that data that they want that gets value to them so they can pull it out and take it from you. And then again, we have things like GuardDuty to be able to help provide you with the information you need from the threat intelligence piece to know what to do. And now, all this tied together, let me give you an example of, we had the pyramid up there before about changing the way you think, about changing the way you behave in the cloud, about trying to solve a business problem with an architecture. And I want to try and have it make a little bit more sense to you and give you a concrete example of something that you can do in this environment. All right, so we talk about cyber relevant time. We talk about the time between a compromise and a breach. So 2018, the Verizon Data Breach Investigative Report identified that the time window from compromise to breach is anywhere from minutes to days, generally speaking. But the chart they had, it showed that the line was down here for minutes and it goes to days, I mean hours, and it goes to days. And what that means is minutes, it's not likely that somebody's going to be able to go from compromise to breach in minutes. Days, it's not likely that it's going to take that long. It's going to usually be minutes. So if we know that the cyber relevant time between a compromise and breach, the time between a compromise and a breach is hours, not minutes, hours. Minutes would be very difficult. So we know this. So what can we do to help mitigate that? So what we do is, let's say every hour you kill all your instances within your auto-scaling group that are web-facing. Every hour, you spin up new ones and you kill the old ones. So that the attacker, they go in, they get a compromise, they try and start looking around to find out what else they can get to, and then all of a sudden they lose connectivity to their instance. They say, hey, what's going on? They try and connect again a couple times. They can't. So maybe they go away, or maybe they come back and try to do another breach. They go through the process of doing a breach. It takes them a couple hours to get to that command and control phase. So they go in there, they start doing it again, all of a sudden they lose connectivity again because you killed the instances. With a load balancer, with an auto-scaling group, and your web servers in the front end, you can use what's called CloudWatch to schedule something every hour to pull a Lambda function that will spin up new instances, so you have all the instances you need. Your customers never know what's going on. There's no performance impact for this. You spin up new instances, get them healthy in the load balancer, and then you delete the other ones. If you make it so that it becomes nearly impossible to go from compromise to breach, what do you think you've done for the cyber economics of the attacker? All right, so these are some things you can do as an example. And now I'm going to transfer this over to Zhang, and he is going to go on with talk a little bit more about how service can help you. Thanks.
Thank you, Darren. So, Darren has talked a lot about security and ops stuff. I'm here talking about serverless, how serverless can help you, and what is serverless. So, again, my name is Xiang Xie, and I'm in a specialist team focusing on development technologies, containers, serverless, DevOps. I'm an SA, and I'm also a developer. So how many developers here today in the session? Yeah, some. So just so you know, StackOverflow.com, every year they run a survey globally for all the developers. Serverless has been ranked #2 as the most loved platform right after Linux. So there's a lot of love and momentum for serverless. Developers started building all the solutions and products based upon serverless. But we all know it takes more than developers, right? We need everybody, all the teams, ops, security, working together to build a greater solution reliably and securely. So, I would like to step back a little bit, talking about what is serverless computing. So before we introduce Lambda, which is our sort of function as service, allow you to upload your code and just run it, we actually already have a lot of service like serverless. For example, S3, our storage service, SQS, our queue service, and like email, SES, notification service. That's great, but we're missing a big piece, which is computing. When we have the service computing, we have Lambda, great things happening, right? So developers can just start developing applications and solutions, upload their code, it just runs. They don't need to care about infrastructure. They don't need to care about security, patching the system, those kind of things. So at the high level, how like serverless applications, Lambda works. So this is just very high level architecture. In the middle, of course, we have Lambda, which is our serverless computing service. It is actually an event-driven system. So we have all the event source over there. We can take a variety of events, including, like, for example, you drop a file into S3 bucket, it triggers event. Somebody updates the DynamoDB table, it also triggers event. Now, even in a relational database, our Aurora database, if somebody updated a table, insert a field, it triggers event. So you can run Lambda based upon those events, which is sort of like a stored procedure in the database world, right? So you can even trigger it with like an API gateway if there's API click. Darren has mentioned that we have a service like a GuardDuty. It also can send events based upon any like security compromise or like somebody did some bad things. It can have send events to Lambda. The great thing is you can build a solution quickly, try to deal with those kind of events. And then you can basically talk to anything. For example, insert something in your database, delete admin user, or change your security group in your VPC, right? Sorry. OK, so why serverless? So first, I'm a developer. From development perspective, it just raises the level of abstraction, right? Everybody is familiar with like VM, EC2 instance. It's just one level above your bare metal servers. Then we have containers. It's abstraction on top of OS. Now serverless. It forces you to think about service-oriented architecture, microservice-based. And again, Lambda, we pioneered in this space. Actually, inside Amazon, we already have a lot of products and services built based upon serverless. It's actually born in cloud, and it's cloud native. It's integrated with our service deeply. Again, we make sure they are highly available, scalable. The nice thing is Lambda is a fully managed service. It actually minimizes your attack surface. So you might ask, what's the difference between a managed service and a service computing, like Lambda? The answer is, yeah, Lambda is a managed service, but it has a different working like model, event-driven, pay as you go. If you don't do anything, there's no event, you don't need to pay for anything. And underneath, it's running on a container. It's not really a Docker container. It's based upon C group and namespace in Linux. And every couple of hours, we recycle the containers. So you really don't need to concern too much about like patching. Like if there's like OS vulnerability, we already like probably patched for you. One example is like Intel CPU vulnerability. Before it's released to public, we already recycled all our like containers for Lambda, so you don't really need to worry about it. So of course, examples. I'm a developer. I always think, like, show me the code. how it works instead of like a slide, right? But before I do that, I just want quickly talking about the architecture for the demo. First, I have GuardDuty. Again, it's a managed threat detection service, continuously monitoring your service, detect all the like anomalies based upon like machine learning or different data sources. GuardDuty has something called fundings based upon different severity levels. So that's a number over there. Anything above like 7, we can say it's really high, which means, like for example, if it's EC2 instance, it means it's compromised. You have to do something immediately to isolate, shut it down. If it's a medium, something really suspicious is going on, you should be aware of and possibly check in as quickly as possible. Low, which means, yeah, you don't need to take immediately like any actions, but it's good. You take a note and address it. So those events I received, it will have those like, severity levels over there. One service I'm going to use is called step functions. So for the developers, if you're working with like serverless architecture for a while, you would understand Lambda basically is stateless. So we run when event comes in. If there's no event, we're going to shut down the container. You cannot persist the state in your Lambda function. So usually you have to use a storage, S3, DynamoDB, or Elasticache, Redis to persist your state. But sometimes it's awkward because you have to move the state from one place to another place. So we came up with this service called step functions. So on the right side, you can see it's basically a state machine. So anybody working like in the computer science world, state machine is a well-known like notion. So it has states start to end, then move based upon event, you move to different states. When you define the step functions, it's really easy. It's just JSON-based. Left side is an example. So it's really a simple service to use. When something happened, you move to the state, you basically invoke a Lambda function to do different things. We can also support something called like activity worker. So if the activity has to be staying there for a long time, or running on EC2 instance, or even on on-prem server, you can do that. When it's finished, it can call back, and the state can like go on. So put everything together. When we have fundings, events from GuardDuty, I'm going to use CloudWatch to pipe events into step functions, kick off the step function, and the step function would call different Lambda functions and to do different things based upon the like severity of the event. One advantage is it's really quick, it's reactive, it's event-driven, right? So I would say maybe currently or in the near future, you would see a lot of vendors doing this type of things. If you adopt like a SaaS-based solution or in the cloud, more and more vendors and the third party or Amazon will move to the serverless world. So it's really good for those people not familiar with service, understand what's the concern, what kind of impact in a serverless world. So actually that's one objective here for this session. So all right, demo time. Hopefully I have connection. So can we switch? Yeah. Oh. All right, that's my EC2 console. So I'm not going to show you this. First thing I want to show you is GuardDuty. GuardDuty is a great service, really simple to use. Literally, you click one place, enable it, that's it. So if you go to like settings, right now I'm already like running it. So I can suspend it, I can disable it, but if you don't have anything like that, which means you only have a button to like enable it. Once enabled, it will continuously monitor your like AWS account. So you actually will receive those like, events over there. We do provide example events. So sometimes it's really hard for people to have like high severity events, but you want to look at it. Get it big for you. Hopefully you guys can see. So that's example. It will tell you what this funding is about. It's about EC2 instance and what resource it affected, the image ID, and if you have tags, then the network interface, the VPC, and what's the malicious action people try to attack. And there's some additional information. So we actually absorb data from different sources. So combine them together and do some machine learning and have some intelligence built to it and come up with this finding for you. There's a funding ID. If you click, you have an event. The event is JSON-based, so it has all the information over there. So that's great, right? Of course, that's just one step. You have the data source. You know somebody's trying to attack you. What if it's the middle of the night? You want to do something, right? You cannot have your EC2 compromised and somebody just log in and do like Bitcoin like mining kind of, or even worse, right? So when we have these events, as I said, I'm going to use CloudWatch, come up with event rules. So I have this GuardDuty funding. The event pattern is AWS GuardDuty, and the detail type is GuardDuty funding. So we can absorb a lot of different events for different sources, as I mentioned, like S3, DynamoDB, but that's only for GuardDuty. And if I click Edit, I want to show you, it can send events to a lot of different targets. So it could be a Kinesis stream, which is our stream-based service. It can send to a queue, essence topic. It actually can just send to a ECS, container-based task, pipeline, a lot of different things, even LAMP directly. But here I'm sending to a step function. So I pick step functions and I choose my step function, right? It allows you to specify a role, so you can make sure the only right person or right role have the permission to execute it. So once I have the step function, GuardDuty events come in, then my step function just kick off. So the next thing I want to show you is step functions. So that's my step function. If I do edit, try to make big for you. So it's a visual flow for step functions. I have a start state. I have a different branch. So when event comes in, I do some classification to see its low, high, medium. If it's like a high, for example, I'm going to send a notification to all the channels. Like for example, if I'm using Slack, if my team using Chime, Amazon Chime, if they are using email, text message, I'm going just to broadcast the message everywhere. Make sure people understand there's a compromised event, like instance or IAM user, I have to take some actions. Then based upon the resource type, I'm going to, like, for example, it's EC2 instance, I'm the quantum instance, and take a snapshot and change the security group, make sure it's isolated. If it's IAM user, I'm going to disable the IAM user. I'm not going to necessarily remove it because I have to probably go back to investigate what's going on, right? So if it's a low event, I probably just send out a notification and send the events into my Elasticsearch cluster to index it, so I can search it and correlate to some other events. If it's medium, we want somebody like a security officer, ops people to acknowledge it. So we send out a notification, then we wait a little bit of time, a few hours, make sure they click some links to acknowledge it. If they don't, we're going to escalate, then send manage a notification, for example. Then at the bottom, it's just my definition. So it's really simple, not many lines. Then you can see the resource is a Lambda function, for example. All right. So since I don't expect somebody to attack me right now, when I write, actually I do have examples. So example event. All right. So first, I want using an IAM user. So that's a test username over there. Hopefully you guys can see. So if I switch to IAM user, that's my user. So you can see the user is able to log into the console. They have active status for their key, SSH key, and code commit permission. So I'm going to copy this piece, go back to my step function, and just run it for here. Okay. So once I started, you can see from here, it just have the input as my event, and going to do the output. So it's as expected, it goes to my high severity branch. So if I go to my Slack channel, I can see right now the timestamp is 3:32 p.m. I did receive a notification in my Slack channel. And if I go to my work mail, then I have a high funding over there, same thing. And if I go to Chime, I'm not going to show you my Chime, but I will have another event over there. So it's done. And if I go back to IAM, I refresh it. You can see it's disabled, which means the user cannot log into the console anymore. And it's not inactive for his access key, inactive for the SSH key, and he no longer have any access to code commit. What if about EC2 instance? So I do have, like, for example, instance. So that's instance ID, right? That event will have this information, which EC2 instance is compromised. And underneath, I want to show you real quick, there's a severity over there. So as I mentioned, anything above 7, including 7, considered high. So go back to my step function. Just try to write. So start running. I forgot to show you the EC2 instance. So I do have the test instance over there. That's my test instance. So you already see, like, security group is isolation SG, then there's no inbound rules, there's no outbound rules, which means this instance cannot talk to any other instance. It cannot have any network traffic outside of instance. So then later on, you can try to investigate what's going on. And also, I'm going to kick off a snapshot, take a machine image. So later on, somebody can go there and spin up another EC2 instance trying to figure out what happened, right? So I'm not going to run all the events for you. So I already have some, like, for example, low events. So it just take another branch, then basically send out an email and do the reporting. The last thing I want to run is the medium. So for medium, the severity, like, is 5, like 4 to like 6.9, considered like a medium. If I start, it just goes over there. And it will wait. I'll make it big for you guys. Oh, that's not good. So it'll wait for acknowledge. I'm going to expanding an email. So there are security events going on. You need to click the link to acknowledge. So if I click it, it acknowledges. If we go back, if I refresh, so yeah, it finished. If I don't do that, after a couple hours, it's going to another branch trying to send out message to escalate it. So that's about my demo. So what I'm trying to deliver the message here is, in a serverless world, you can react really fast, rapidly based upon the events. For all your security concerns, compromised instance, IAM users, you really cannot wait. You really want to have some event-driven solutions to facilitate. It doesn't necessarily mean you have to build your own solutions. If you adopt some third party, other vendors, they better to also adopt some event-driven, rapidly reactive solutions. Chances are very likely they also build on top of serverless. So you guys need to really understand how security works in a serverless world, and hopefully from this session you can understand how serverless can help you to address all your security concerns. So with that, I think I'm done my demo. We're going to take questions off the stage. Feel free to ask us questions. That's it. All right. Thank you.